Alright, if you watched the last video, we reviewed on how to simplify something called a rational expression. And rational expressions are fractions with variables in them. So we're looking at really messy fractions. And we only worked in the last video on basic ones. So now I'm going to review how do you do one. I call it a pull-out. It's really mathematically more, we'd want to say something like dividing by a greatest common factor. But here's what they look like. Let's just take a look at these. Once you take a fraction, like let's do something like this, 4x squared over 6x to the third y, and you want to simplify it, it's really easy to break this down into a little bit of parts. So like 2 times 2 is 4, x times x is x squared, 2 times 3 is 6, x times x times x is x to the third, and we have that y. And all you do is kind of go through and match things up. Where do we have pairs? Like we have a pair of 2's here, some x's we can circle, and what's left over? What's left over is our answer. We have a 2 on top and a 3xy on bottom, and that's my answer. That type of problem is fairly basic, and I call it basic because the fraction didn't have any adding or subtracting involved. What I want to look at today are these ones that are a little bit harder. If I had taken this type of problem and changed it, maybe made it something like this, 3x plus 6 over x plus 2. Once I throw that plus sign in there, that addition sign, I can no longer do this trick where I don't really want to call it a trick, but I can no longer use this property where I can circle the power of 1s. I cannot circle these x's. That would not make any sense at all. In fact, what I want to do is I want to see that this is grouped together. 3x plus 6 and x plus 2 are in groups. You can't cancel out a group unless they match. So I got to study these groups. 3x plus 6. Is there a number I can divide both 3 and 6 by? We call this like a number I could pull out of them. Well, I could divide each of these by 3. So I'm going to write divide by 3, divide by 3. It's really small. If I do that and I pull out a 3, 3 divided by 3 is a 1x, so x, plus 6 divided by 3 is 2. So really I haven't done anything to this problem other than put the 3 in front. If I distributed the 3 back in, I'd end up back to this, 3x plus 6. So I pulled the 3 out. On bottom, can you pull anything out of x and 2? No, they have nothing in common. They're just x plus 2. So I'm going to leave it like that. But you can see after doing a little bit of work, here's my power of 1. It's the matching groups. The entire thing matches up. That's what I get to cancel and get rid of. So what's left over is 3. And that's the only thing left over. And that makes my answer, 3. So take a look at like something like this. If I gave you 2x minus 4 over 3x minus 6. Now I've got subtraction signs. It's the same as addition. You want to group these together. Even though the problem doesn't have parentheses, go ahead and do it yourself. Put the parentheses around these groups so you can see them. And then ask yourself, what can I pull out? What can I pull out of 2 and 4? What do they both divide by? Well, they divide by 2 and 2. So if I pull out a 2, what's going to be left over? 2 divided by 2 is 1x, minus 4 divided by 2 is 2. So that's what's left over. On bottom, if I pull out a 3, what's left over? So I'm going to divide by 3 and divide by 3, pull the 3 out, then I'm dividing by 3 divided by 3 is 1x, minus 6 divided by 3 is 2, and again, there it is, my power of 1, this thing, x minus 2 and x minus 2. So what's left over for my answer? 2/3, and 2/3 is my answer. Some of these pull-out problems are kind of easy, and then some of them can be actually really hard, I think, to learn. So I'm just going to kind of work through these examples for a little while, kind of show you different types. There are all these weird ones with adding and subtracting. So that's kind of what you're looking at here. So like, let's say you had 10a squared over 5a plus 20. 10a squared over 5a plus 20. There's an adding sign, so this is needing to be grouped together. There's no plus sign on the top. 10a squared is 10a squared. So what I'm going to do is I'm going to look at this thing and think about on the bottom, what could I pull out of 5 and 20? Well, I could divide them each by 5. And I'm going to rewrite this fraction. I'm going to pull the 5 out, and I'm going to have 5 divided by 5 is 1a, plus 20 divided by 5 is 4, a plus 4. On top, I still have a 10a squared. So let's see, the 10 could be 5 times 2. We could change it to 5 times 2, and a squared is a times a. And I see my power of 1. It's these 5s right here on the outside. I think that's it though. I can't circle the a's because this is grouped together, and the whole group would have to be able to circle, and it's not. So I have 2a times a, so a squared, over a plus 4. And I can put a parenthesis around a plus 4, or now that I'm done, I can kind of forget about the parenthesis. But that's going to be my answer. I can't circle the a's because they don't match in the groups, so I leave it be. So try one of these things. Pause the video and give this a try. See if you can do this. I'm going to give you this one here. What if I gave you 6x minus 4 over, and I gave you on the bottom 2 parentheses, and inside these parentheses we have x plus 6 and maybe 3x minus 2. Well, they've already kind of done some of the work for you. They've thrown some parentheses in there, they've grouped it together. The one thing they forgot to group for you is the top piece, so you got to do that. Group 6x minus 4. And let's see if anything matches. What can you pull out of 6 and 4? Well, you can divide them each by 2. So I'm going to divide by 2 and pull out the 2. And if I divide by 2, 6 divided by 2 is 3x, minus 4 divided by 2 is 2, over. On the bottom, can you pull anything out of x plus 6? No, it's already in its best form there. 3x minus 2, you can't divide by 3 and 2, anything that'll work, so 3x minus 2 is the same. But that's kind of okay because look what my power of 1 is going to be. It's going to be 3x minus 2. 3x minus 2. Those are going to go away, which means my answer is going to be a 2 over x plus 6. And you got to stop yourself. X plus 6 is grouped together, so this is my answer. Don't try and say that the 6, this is what I see people do. The 6 is 2 times 3, and there's a 2 on top, and they want to cancel it. You really can't do that. As a group, it's got to stay together. It's got to stay in a group. Okay, so here's an example of one that's a little trickier. It's going to have some more variables in it. Imagine you have 4x squared plus 2x. 4x squared plus 2x over 6x plus 3. 4x squared plus 2x over 6x plus 3. Okay, so we're going to group these together. Naturally on our own, we kind of see the groups. We're going to do our pull-out process. We're going to divide. Now the bottom's going to be easy. Let's see. We're going to divide by 3 down here and pull out a 3. So let's just do the bottom first. Pull out a 3. If you divide by 3, 6 divided by 3 is 2x, and 3 divided by 3 is 1. So easy. On top, what are we going to pull out of 4 and 2? Yeah, we're going to divide by 2. But there's a catch to this one. What do they both also have? 4x squared and 2x, they both have x's. So I'm going to divide a 2x out. I don't know if you can see how small I'm writing 2x there, but I'm going to pull out 2x. 4 divided by 2 is 2, and x squared, if I pull an x out, is 1x left over. Plus 2x divided by 2x, 2 divided by 2 is 1, and x pulling out an x is gone. It's just 1. So here's what I get, 2x plus 1 and 2x plus 1. This is my power of 1, this. It's going to go away. So what's left over? 2x over 3. 2x over 3. And that's my answer. So pull-out problems are basically any time you run into adding and subtracting, you want to look for what can you divide the terms by, what can they both divide by, and you can pull it out in front of the parenthesis. And you want to group things with your parentheses. Use parentheses as much as possible to group any adding and subtracting problem together. Hopefully that helps. I would go on and watch the next video. It's called factoring.